Welcome everyone. Thank you for attending the CAD to GIS webinar. This is a transportation webinar that we're going to be highlighting CAD to GIS integration workflows. And my name is Eric Rodenberg, and with me today is Gary Waters. So what we're going to do here is get started and show some different workflows, but I wanted to start off with a quick demonstration showing what is possible with CAD data once it's been brought into the GIS, and the best way to show that is through a demonstration. So what you're looking at is some CAD data that was imported into GeoDatabase and using City Engine was converted into a web scene. So as I zoom in, you're going to start to see the roadway, you're going to see some trees, water, and then we'll see some utilities as well, like underground pipes. So what this is highlighting is the ability to bring CAD data in and extrude features and visualize those features as they look underground and above ground. So not only can we see things like above ground utilities, but we can also visualize underground utilities as well, like a culvert or underground electric lines or underground telephone lines. And this workflow really highlights what is possible with that data. And taking that data and combining it with City Engine, we can make these very powerful and rich visualizations that can be taken to the web. And that's exactly what I've done here. So everything I'm going to be showing today is utilizing StoryMap and the capabilities of online, of ArcGIS Online specifically. So it's a very powerful way of telling a story, and it's a very powerful way of visualizing your data. So with that, let's go ahead and take a look at what you have to do to make all this happen. And it really starts with strong integration requirements. There's really three things that make it necessary to ensure a successful CAD conversion. And the three things are location, submission standards, and attribution. We've got to start with data that has location associated with it. A lot of times designers will build CAD files that are in paper coordinates, and those paper coordinates don't mean anything to us on the ground, and that can create problems. Standards allow me to ensure that center line is always a center line, no matter what CAD file I'm working with. So we'll get into that detail in a few minutes. And then we've also, there are workflows where attributes can be tied into the CAD features, and then those attributes can be imported into the GeoDatabase. And we'll get into that in a little while. So first, I want to dive specifically into location. And there's really three ways that GIS can work with CAD. When we are dealing with issues like a missing georeference, where data is designed in paper space, what you'll find is that the data will not fit anywhere on the map. It'll be, it'll start at 0, 0, or what we call Null Island in the GIS world. So this is the land of misfit CAD files. So this is where misfit CAD files go, and they don't line up with anything. So really at that point, your only option is to georeference the file. And you do that by using our georeferencing tools in ArcGIS to transform the CAD file and associate it with physical coordinates on the ground. And that usually requires you to line up the CAD file with features on the ground. So generally we'll look at things like roadway intersections and physical features, like if we see if we've got power lines or power poles on the file, we can line those up with power poles in an aerial image and actually line up the file. But that doesn't always give people the best, most comfortable predisposition when they're dealing with the CAD data, because if that's the best you can do, it's not always going to line up perfectly, and that can be a challenge to a lot of folks. So the other way is we can require that missing projections be And when you look at a missing projection, this is an example of one. So I'm loading up a CAD file in ArcGIS Online that's missing its projection, and what you're going to see is that it is showing up pretty much so in the middle of Africa. So what's interesting about this CAD file is it is represented in Alaska, actually. So as we zoom in, it looks like my CAD file is still rendering or thinking about rendering. When the CAD file renders, it comes in the middle of Africa. So that's not really what we're looking for. That's not where we want the CAD file to show up, and I'm not sure why it's not drawing at the moment. But basically, this CAD file it has unknown coordinates. It's missing a projection file. It doesn't know where it's supposed to be on the ground. So it's up to me to fix that. So a best practice is to, if the CAD files have been projected, but they're just missing the projection file, it's really a simple fix. I can take, in this case, I'm going to show you an example. I have a series of CAD files. Now in Alaska, they have multiple zones, multiple UTM zones, roughly 5 UTM zones that make up Alaska. And when we're dealing with CAD files in multiple zones, what we can do is we can make up folders for each zone. So I happen to have 2 CAD files that live in the same zone here, and this is zone 3, or actually we need to look at the CAD file or the projection. So this projection is for UTM, it's Transverse Mercator, and it's State Plane Alaska 3. Sorry, I have that wrong. It's State Plane Alaska 3. So there's 5 state plane zones in Alaska, and I've got this file that represents zone 3 in Alaska. So any of the files that live in this folder are going to utilize this projection file as long as you name it Esri_CAD. So for instance, if I had, if my state was broken up into 3 state plane zones, I would have 3 folders, 1 for each zone, and then I would have all the CAD files that are supposed to be in zone 1 in the zone 1 folder, all the CAD files that live in zone 2 in the zone 2 folder, and all the CAD files that live in zone 3 in the zone 3 folder. Then I would have a corresponding projection file for state plane zone 3, but I would name it Esri_CAD, and I would put it in the case of the zone 3 projection file, it would live in the state plane zone 3 folder, and it would be named Esri_CAD PRJ. For zone 2, I would have the file live in the zone 2 folder, and again, it would be named Esri_CAD PRJ. As long as ArcGIS sees that file, it'll read it, figure out what zone the data is supposed to be in, and project it to the right projection. So here is the results of that. So when we look at a CAD file that's projected and georeferenced, it's going to line up exactly where it's supposed to. In this case, along the Richardson Highway, just west of Valdez. So if we give this a moment, you'll start to see the file come in along the Richardson Highway, maybe. When it does finally draw, you'll see the entire CAD file line up right over the highway. And I've got another example that you'll see in a few moments if this doesn't show up here, but that's generally what we're looking for. We're looking for a CAD file. Here we go. So I'll just go over to the one I know is right over the highway. So this is my CAD file over the Richardson Highway, just south of Valdez, so we can see exactly where it is, projected in the correct coordinate space, georeferenced to the correct space, and lining up exactly where it's supposed to. And there's actually 2 sections of road that they did work on, this section around Browns Creek, and then this section at this curve on Alaska Interstate 4. All right. So that is a big challenge, trying to get CAD data that actually draws where it's supposed to. And like I said, there's really three schools of thought there. You can georeference it yourself. You can, a lot of times designers that do project their files, they don't always include the projection. So then it's just up to me to provide that projection. And then when they do provide the projection, everything just works exactly as it's supposed to. And that's really the goal. So having good submission standards that requires a projection file is always the best option. And that's where we're going to go to next, is to talk about submission standards and why submission standards are so important to a design operation. So when we have some, yeah.
There's a question about just verifying that there's an equivalent workflow for what you just did with the AutoCAD drawings for MicroStation drawings.
Yeah, so as long as you have the CAD file, as long as you have the projection file in the folder, DGNs, DXFs, and DWGs will all behave the same way, provided that they've been projected and georeferenced. As long as you provide the CAD file or the projection file in the folder, ArcMap will do the rest and ensure that it gets where it's supposed to go on the map.
Okay.
Does that make sense?
Yep.
All right. All right, so when we're talking about submission standards, there is a thin margin of error. Naming conventions mean everything. So here we have a file, and I'm highlighting this V drive center, CNTR. This is the center line of the CAD file, and when it comes over as V road center. The point is we always want to ensure that a center line is always a center line. So if we have a CAD standard that specifies what the levels are supposed to be, every time I bring in my files, no matter what file it is, they'll all work with the geoprocessing tools we put in place. The point of this is yeah.
There's another question if you don't want to be interrupting.
Yeah, sure.
The Esri _CAD PRJ file, yes. What exactly is in that, and how do you create it?
So it's really simple. Essentially, you're going to take your so a PRJ stands for projection file. So ArcGIS ships with about, I don't know, 500 projections, and they all come into ArcGIS as PRJ files. So the PRJ, the projection file, is a text file that looks something like this. Let me pull it in. It's a text file that defines the math and the false easting, the false northing, central meridian, all the information that ArcMap needs to place data on the map. So that's what a PRJ file is. By default, there are PRJ files for every projection we support. So in NAD 83, for instance, I live in Ohio. There are two zones in Ohio. There's Ohio State Plane North and Ohio State Plane South. And there are multiple state plane projections. There's state plane feet, there's Harn, there are NAD 27, NAD 83. So there are multiple projections that exist for any given state, depending on the area you work in. There's UTM projections, which are divided up around the globe. And each one of those projections is generally named something like this: NAD 83, in this case 2011 State Plane Alaska, and then it's usually .prj. So depending on the region you're in, you would take that file, and like I said, they're embedded with ArcGIS. I would copy it and I would rename it Esri _CAD. And then I would stick it in the folder for the appropriate zone. And then usually I would name the zone. Like here, I should probably name this CAD Files Alaska Zone 3. so that I know that this belongs to zone 3. So when I'm looking at this, I know that all the data in here is zone 3, and it looks like it didn't rename my folder, but you get the idea. So, like I said, all the projections come bundled with ArcGIS. I'm going to pick the ones that are appropriate for my state, and I'll rename each one, depending on the number of zones I have, Esri_CAD.prj, and I will stick it in that appropriate folder with the CAD files. Does that make sense, Gary?
Mm-hmm. Yeah.
Right.
So if you have a file that's using a modified state plane coordinate system, was there one of those parameters? I saw a false easting and a false northing. Is that where you would handle a modified state plane?
Yes. You would actually do it in the coordinate. There's an editor, and it's not showing up here in my version of catalog right now, but if I can get the coordinates to show up, and I would see all the different files, and I can edit those manually. I can edit those through the editor in our catalog, and then copy them and save them and do all that. But I don't have that node showing up right now in catalog.
Okay.
All right.
And by the way, I'm sorry, it's Gary, and my computer like stopped functioning literally about 30 seconds before the webinar started. So obviously a few of you have figured out to ask questions. You can type them into the questions box there, and we'll try to answer them as we go on. So feel free to ask questions.
Yeah, so anyway, back to the CAD submission standard. What we're trying to ensure here is that whatever the name is, it's standardized for every CAD file that comes in. So Alaska, for instance, has a standard. Colorado has a standard, and a lot of the state DOTs have published standards, or they're starting to get them. And what that means is whenever someone submits, whenever a designer submits work, they are generally supposed to follow that CAD submission standard. And the whole purpose behind that is so that you can take the CAD file and process it, and they're all going to behave the same way. Otherwise, I could get 10 files and have to modify my processing 10 different times to work for each file, which is what we're trying to avoid. By having a standard in place, I know that the drive center is always a center line, and it's always going to be a center line on every CAD file that comes in. Now, let's say you only had a CAD standard for the last year. Everything that happened before that last year means you're going to have, if you come up with a process, you might have to modify that process for every CAD file older than a year old. So the point is everything before the standard is going to be up for complete modification and interpretation. So that's what makes working with CAD so difficult at times, is you might have 20 files and every one of them is slightly different. But if you have a CAD standard, from that point forward, it generally makes it easier to work with the data. So I'll just pause there. Any questions so far?
I think you're good.
All right, I'll keep moving. So another challenge that we have is the way features are rendered in CAD are different than the way they render in GIS. For instance, this is a street sign. So we have a street sign and we have a light. The street sign is the green squares with the circle that represents the signpost. The squares represent the sign, the sheet. And then you have a CAD light, which represents the pole and the arm and then the light. In the case of the CAD sign, that's actually 14 different lines that make up that feature. And in the CAD light, that's actually 8 polylines that make up that light. In GIS, we would just represent that as points. So trying to get that feature to come across can be a little bit difficult at times. So you're going to have to do processing. And generally what I had to do in the case of the signpost, I had to create a centroid at the center of the signpost. So I had to turn this signpost into a polygon and calculate the centroid to figure out where the actual signpost is on the map. And the same thing with the light. I had to figure out where the signpost or where the light post was and generate a centroid at the center of that line post to get a point, because we would represent those features as points. So that is a very difficult challenge to face, trying to figure out, because when you select the whole sign, all these features select. So we have to generate something into a polygon in this case, because we have these lines that form an area that we can generate a centroid. So to help me do this, another thing we typically do is in GIS, we might render the sign and the post as related tables. We might actually have a sign post table that's got the information about the post, what kind of material it's made out of, what the base is, how it's attached. Is it embedded in concrete, or is it just embedded in earth? How is it actually filled in? What's the height of the signpost? What's the material? Is it wood? Is it metal? So you might have all that information. And then the same with the sign. You're going to have all the information about the sheet. What kind of sign is it? What's the MUTCD code? What is the reflectivity of that sign? What is actually on the sign? So you might have multiple things that are tied together that CAD just isn't going to tell you directly. So that's a challenge. And so getting all this data to work out can be a challenge when we're trying to convert CAD to GIS. And so one of the things that we have seen, and I've only seen this, I see this very seldomly, some CAD designers will actually tie access databases with attributes to the CAD file. So if they provide you with the CAD file and an access database, we can take those attributes through the data interoperability extension and actually pull the attributes in to GIS so that they live with that sign. So whatever we capture in, so if we have an item name, a part number, a dimension, you know, in the case of a sign, you might have the signpost material, you might have the base, you might have the height, and you might have several different values. And if those are tied to an access database, we can pull those in through the data interoperability extension. It gives me the option of assigning an access database where all the attributes live, and then it will generate the relationship based on how that CAD file ties back to that access database. Another challenge is, can we actually get to the Z values, to the 3D data? And as you saw in the very opening demo, the answer to that question is yes. I was able to actually access the Z information. Not all CAD files have Z information, but when they do, we can extrude that information out and create 3D features. So you saw I was able to generate trees, and I have another version of this CAD file where I've got all the power lines that we don't happen to see in the power line pole, the power poles. We had the underground culvert, the outfalls. All that information has Z values behind it, and so we were able to extrude that out. And I did that just with the Esri geoprocessing tool. So I can create 3D features as long as I have Z values. And in the case of my CAD file, it had Z values associated with it. So we were able to extrude out all that information. Now, the question is, how do we do it? I put together a script, a geoprocessing model, which I'm going to show you at the end. I've got it actually out on GeoNet now, that anyone can download, and it allows you to convert CAD to GIS. And if you've got 3D features, 3D CAD features, it'll turn those into 3D point features or 3D line features. So we can identify the CAD points and then copy those to 3D points in a geodatabase. And then we can use the layer names to determine what the feature class names are going to be, and move everything over to a geodatabase. And then from there, I was able to take it all into City Engine. So I identify the CAD points by their layer name, and then I use copy to 3D point to create a 3D point feature class. And the same is true with lines. I was able to identify CAD lines by their layer name, and I got elevation data from the intersecting point CAD point geometry. So every line has a node on it and a point node on the end of it, and each one of those nodes has a Z value. So from the Z values on the nodes, I was able to calculate 3D lines and turn a culvert into a 3D line. So if the culvert has slope, which all of mine do, you'll see that they are sloping down towards the riverbed. In the case of that opening demo, everything slopes in the correct direction towards the main river, just to the south of Richardson Highway. And I do the same thing. I can do the same thing with polygons. I can actually create polygon surfaces. I can check for closure. I can interpolate an elevation from contour lines. So it's possible to generate 3D contours or 3D polygon features as well. And
hey, Eric, we have a
yeah.
We have a question here. The question is, can you create a lookup table for the symbols library with a unique identifier in such a way that that point centroid would display using the symbol instead of just a point? I think they're trying to figure out how you would display more than a point. Like if there's a specific symbol that you wanted, maybe similar to the symbol that's used in the microstation drawing.
Yeah, I haven't had much luck there, but I haven't really explored that too deeply. So I can't really say from my experience. You could probably do that. I haven't done it.
Well, if you can create symbols inside of ArcGIS. So I guess if you recreated the symbol set you're using in the CAD drawing, you could connect them to the symbols that you've brought over from the CAD environment.
Yeah, and that's sort of what I'm doing here in this file. So in this file, now I'm not sure how closely this resembles the actual CAD drawing in AutoCAD, but I'm using the CAD, I'm using our Esri CAD symbology set to symbolize all these features that you see on this map. And I'll get into this map in just a moment in a demo to show what we're going to show. But everything here is symbolized exactly how the CAD file would be symbolized if you were looking at an ArcMap. All right.
Okay, there's one more question. It just is the data interoperability extension compatible with DGN microstation drawings? I know the answer is yes.
Yeah. Now in the code that I put in the geoprocessing tool I put together, I don't use the CAD interoperability extension, and it also works with DGN, DWG, and DXF. So the tool I put together is not using data interoperability. It's just using the out of the box ArcGIS geoprocessing tools. And I'll show you where that is at the end. All right, so as we saw, I was able to actually extrude out features and turn them into trees and the road and water. And all that was done with City Engine and ArcGIS, and it could be done with ArcGIS Pro as well. And actually, City Engine has quite a few tools to do the extraction of elevation data and imagery, so that when you bring your data in, like for instance, when I brought in this scene at the very beginning, I'm gonna jump back to the beginning real quick. This the imagery in the 3D portion of this, I'll pause this when we flip over horizontally, so you can see there's some elevation in this data. That all came from ArcGIS Online. So City Engine has the ability to clip out an area that is represented by your CAD data or by any GIS data for that matter, because that's what we're actually working with here is geodatabase. So once we converted all the CAD data to geodatabase, we're using City Engine to represent it all. And City Engine has some pretty unique and interesting features. So when I zoom in on this water, and you'll notice the road disappears, it's trying to render at a higher, my refresh rate's not high enough to keep up with all this data. So you can see that the water appears like it's moving, it's glistening like it really would. So that's just an animation that's on the water. And then we've got a pavement animation, and then of course, I'm using the trees, and then all this flows downhill towards this riverbed. So if I were to actually zoom in to the culvert, if I can get down, it actually slopes downward from right to left towards the river. So it's actually sloping at the correct angle to drain water down towards the river. So all that was done using City Engine, and we've got some really nice tutorials. I followed a tutorial to do all this, to get all this data to display. And then everything we do, everything generally that we do is with these tools is COTS. So the CAD integration, the tools I built to convert DXF, DWG, or DGN using Model Builder, those are all out of the box. So nothing, I didn't do anything custom. There's no custom code. And then I'm extracting all that data out of the CAD file. I'm transforming it and loading it into a geodatabase. And then from there, I'm using 3D scene visualizations and scene tutorials to visualize all the data. All right, any questions so far?
You're doing good.
All right, so now I'm going to take you into another demo. This time I'm going to show a demonstration of CAD to GIS back to CAD. And I'm going to do this in ArcGIS Online with Collector. So the idea is I want to give contractors in the field the ability to update and modify the as-built CAD rendering and show things change as they actually would in the field. I know this is a question that comes up all the time with the DOTs, and we put together a little workflow that highlights this. So before I actually get into this, to the demo, I created this feature service that we see here of which is from a CAD file. This is actually a hosted feature service in ArcGIS Online. And the geoprocessing tool that I'm going to show is called CAD to WebMap. So I literally created this tool, CAD to WebMap, which takes a CAD file, extracts it out to a geodatabase, to an MXD actually. So it extracts it into an MSD. It applies a symbology set that matches the our CAD rendering symbology, and then it takes that and publishes it to ArcGIS Online as a hosted feature service. So this tool takes a CAD file, extracts it to a geodatabase, creates an MXD, publishes the MXD as a service, and now what I'm going to show is editing that service. And again, this code is also going to be, it's available for download. So I've got this CAD file that I've turned into a feature service, and I'm going to edit it using Collector. So this is my iPad. Yeah.
Before you get into Collector, do you have the input, the processed, and the output files in a file geodatabase that you could share that for this example? Like, can you share the data that you have used in all of this? Is that part of the link you're going to? Okay.
Right. I'm not sure if the data is part of it, but I'll check.
Okay.
All right.
But you're going to provide everyone a link where they can go look at the CAD, the files you've used, the way that you've processed the data. All of that's there. You're just not sure that the data is included.
Yeah, I need to check and see if the data is part of the zip file. I'm not sure if it is or not.
Okay.
It's been like a year since I'll have to go look.
Okay.
All right. So we're looking at collector, and I'm going to zoom in on a culvert. The culvert is the blue line. This guy right here, this polyline 6948, that's my ditch pipe, or as we would call it, a culvert. And you can see my sign over here in green with the boxes in the green. We've got a light pole just to the north of me in red, and then I've got the culvert. So I'm going to edit the culvert. So imagine that I'm a contractor, and for whatever reason, we weren't able to actually put the culvert here at this location, maybe because of the maybe a geotechnical issue. Maybe there was some bedrock we couldn't cut through. Whatever the case, I need to update the drawing to reflect where we actually place the ditch pipe or the culvert. So I'm going to click OK. Now I'm going to just select the point, and I'm going to move it. Let's undo that because I didn't want that to happen. Let's do that. There we go. So I have moved the culvert. So now I'm going to update that. And now let's take a look at the outfall. I'm going to move the outfall now, and we'll edit that. So in the next version of Collector, we are going to be able to support snapping. Right now I don't have snapping, so this is kind of going to be hit or miss. There we go. All right, so we'll update it there just to get the point across. So now, so I'll zoom out so we can see that the culvert has changed. Let's go back into ArcMap, and I wish I was zoomed in on that location, but anyway, we'll zoom in, and you can see that the culvert has now moved based on the edit I just made. So we can see it's moved. It was inside this green triangle. It was inside of here, now it's out, so we can see that it's updated. So now I'm going to jump over to my content, and this is the feature service we were just editing. So I'm going to export this to a file geodatabase. So we'll click on this guy. And once it loads up, I'm going to export this out to FGDB. I'm going to get rid of this text at the end, and we're going to call this file geodatabase. And then we'll call this CAD feature service extract for the summary. So I'm going to export this. It's going to put it in my CAD projects folder. This takes a minute or so to write. Basically, it's generating a zipped up file geodatabase. And then once it generates that zipped up file geodatabase, it's going to turn it into an item in ArcGIS Online that I can download. Now, I could have automated this process as well. I could have used the Python API, Jupyter Notebooks, and basically done this extract in an automated way that would just completely create the file geodatabase, download the zip file, unpack the zip file, and turn it into a file geodatabase on my desktop. I just wanted to show this process, though. I think it's always good to see parts of the workflow carried out step by step. So I'm going to go ahead and I'm going to download this now. And when
Eric,
I download it,
while
sure.
that's downloading, I don't know if it takes a minute. It looks like there's like some fairly significant stuff you do on the GIS side, or even some design considerations on the GIS side that may have design considerations of the DGN file that you might be working with, what would you suggest to a CAD-oriented person, so the MicroStation user, in order to help facilitate this migration?
Yeah, there is quite a bit of knowledge required of ArcGIS. A good place to start might be working with services. I mean, if you want to get this up and running quick, you could work with our services group to help. If you've got a little bit more time on your hands, you could certainly do ArcGIS training on your own. But the quickest way would be to actually engage with services.
Okay, so I guess I actually thought of, in many of these organizations, they may have GIS resources inside their own organization. If they're on the design side and they're trying to get this moved over to the asset management folks, for instance, there may be GIS resources inside their own organization. And it looks like there might be some education that you would want to do in terms of learning the way that ArcGIS creates points, lines, and polygons, and then you can attach any symbol you want to those features based on attributes. So it might help with understanding, like when you draw that 16-line pole looking or signal or whatever you have in your file, what do you need maybe in a design process? There might be a placement point or a specific point that you attach to that sign in the CAD file so that when it comes over, it facilitates some of that.
Yeah, I think that's true. I think the best organizations that at CAD integration work very closely with the GIS folks. I think there's got to be a good understanding by the GIS folks what CAD needs, and then you as a CAD person, a designer, you need to really work to understand what the GIS needs, because like we said, the needs are a little bit different, right? The way we represent a sign is completely different than the way CAD does. So if we can get through those I call them translation, like English to Spanish translate. If you can get through those initial hurdles, you're going to be poised in the long run to really be successful at CAD to GIS integration. It's not easy. I mean, it does take a little bit of work, a fair amount of work at the front end to get it all to work. But once you got it working, it's a pretty foolproof workflow once you are able to pull all the data in successfully. All right, so I just exported out the file geodatabase, and it's in a zip file sitting on, and I downloaded it. So I downloaded it as a zip file on my desktop. Now I have a second tool, and again, as I said, I could have run this directly, exported it, extracted it, turned it into a file geodatabase and been done. But I'm going to do that here. So basically, I'm telling it what the name of the service was, where the file is located. So notice I didn't tell it to go into the subfolder. I just provided the root folder, and it will figure out based on the project name where to go from there. And then I tell it what format I want to write out to, and where the seed file is that I want to use for the symbology. So I can point to a seed file and seed the CAD file with the symbology of that we already use. So now I'm just going to go ahead and run this guy. So I'll click OK. And as it runs, you'll see there's my file geodatabase. It got renamed. And you'll see a couple other files fly in. So it's pulling out the points, the lines, the polygons. Now it's writing a DWG file.
So Eric, is this process that you're showing right now getting the data? So you showed going from CAD to GIS, you edited the data using collector. Yep. Is the process that you're showing right now taking that collector edit and pushing it back into the CAD environment?
You got it. You got it.
Okay.
So now in the CAD file, I'm going to jump back into catalog. I'm going to close this. So this is done. It worked. It took 33 seconds. Now I'm going to go in and I'm just going to refresh the folder. Actually, I don't even need to refresh. It's all there. So now I'm just going to click on this guy, hit preview, and there is my culvert. There it is. So it updated successfully. We see the location of the culvert, and we did our change. We made our change, and the change is reflected in the CAD file. So that is the workflow. And then if I look in the geodatabase that I just pulled down, it's got the same file. So there's the culvert as well. So we see that culvert in both geodatabase and in the CAD file. So that would be a workflow I could use to go from CAD to GIS back to CAD. All right. So there we go. Bear with me here. There we go. So we took our CAD file, we created a file geodatabase, published that as a hosted feature service. We did our editing or our redlining in Collector. Then we pushed those edits back down to the ground as a file geodatabase, and then turned that into a CAD file that a designer could use and review. So then from there, I used Collector to collect the data. I could have used my phone. I used my iPad, but that is the process for visualizing CAD. Now, I've got just a couple slides left. So we, and Gary probably will talk more about this. We are working right now with Autodesk, and I know Gary wanted to say some things, but one of the things that you could also do in addition to the work we're doing with Autodesk, which is going to allow us to do editing in ArcGIS and then push those edits back out to Autodesk, is we could do validation as well. So it's possible using geoprocessing that I could validate whether or not a CAD file has all the necessary requirements. So I can check to see if it's projected, because projected CAD files will come in with an extent, and that extent's either going to be paper space or it's going to be a coordinate space. So I can check for coordinate space, and I can see if that file is georeferenced. And if it's georeferenced, I should be able to figure out if it's got the necessary point layers, line layers, polygon layers, and then I can also check if it's got attributes. And then once it meets all those checks, I can validate.
Actually, it might fall into this a little bit, although, so there's been a couple of questions when you push that data back to the CAD environment about how you would ensure that you're meeting the CAD standards. I think the level or layer might be preserved, but if you had a block or a cell or some, like those symbols where you were showing before that maybe turned into a point, if you wanted them to look like they should have looked in the CAD environment, is there a way to make that happen?
Yeah, that's challenging because the nature of the way that data is rendered. Generally, I can do it with the lines, but with the symbols. Now, if we can edit the insertion point, we might be able to do that as opposed to the actual symbols of the sign itself. But that would require a little bit of testing and work to make sure that all stays preserved.
Okay. So there might be something that you would have to do. So you've done some manipulation of the CAD data to make it work on the GIS side. Maybe there's some equivalent work that you might do on the CAD side to
There
take
might be.
some of the data and process it.
Yeah, that's accurate.
Okay.
Um,
Do you know of any? Do you know of any states that are exercising this workflow, that are going through the whole CAD GIS back to CAD to GIS, like that life cycle?
I think Massachusetts taking on a project, aren't they?
They are. They've been doing some work to get the data, but it's usually been flowing from the CAD environment to the GIS. We're getting ready to, well, actually, we're engaged in a pilot project to do that entire life cycle. But I don't know if some of the other states or customers have that life cycle in place all the way around. If any of you on the online don't mind me mentioning your organization, and you send me as a question format that we're doing that, I'll be happy to share that.
Yeah. All right, so really that's all I have for today. Those few demos that highlight the ability to bring CAD over to GIS and then back into CAD, and then oh, I do want to show one thing. I almost forgot. Let me just pull up. Bear with me here. I might have to just go. So we'll be providing a link. I'll just do it this way. Let's go to GeoNet. So we'll be providing a link to these tools and to the tools that I put together.
While you're looking for that, Illinois DOT said they're working toward making the CAD and GIS environments work in a more integrated fashion.
All right, so here we go. So I posted all the tools, and we'll send a link out. Ray, at the end, I'll get him this link, and then we'll get this out to everyone. So once you have this link, you can go out to GeoNet, and I have a post about the tools, how they work, what's included, and where they can be downloaded. So they'll come up here, and you can just download them right from the page. So you can click on any one of these that you're interested in. And I've got videos for how they work. And I'll check to see if I've got the data. I may have included the data, but I don't remember. So I need to look. And then once you download these, and like I said, if you just click, it'll start downloading the tool, and they'll work on, I released them for version 10.2, 10.1, 10.3, and then anything above 10.3, the 10.3 version will work. So if you're using ArcGIS Desktop 10.6, you can download the 10.3 version of the tools, and they'll just work. So I do have them published in a way that they'll work on, depending on the version of the software that you use. So you can go get them here and then start working with them. And they may require some tweaking on your part, but because everybody's CAD standards are different, but they are out there for everyone to use.
Hey, Eric, there was another question about the CAD file validation that you were showing. That works on MicroStation files as well, right?
Yeah.
That's not specific to AutoCAD.
No, that's not specific to AutoCAD. That should be platform independent. Basically, we can read all three. We can read DWG, DGN, and DXF, and all three virtually, although they are a little different, we can work with them practically the same way, and we can do the same sorts of validation against all three.
And just so you know that people are paying attention to your screen, you got a comment that everything was looking really good until they saw the Wisconsin helmet.
Oh, that's not Wisconsin. That's Wittenberg
Oh,
University.
oh, okay.
Yeah,
There you
that's
go.
Wittenberg.
That'll make someone happy.
Yeah, Wittenberg is in Ohio. Small school, 3. We look the same. The W is slightly different. It's got that, we call it the meat hook. It's got the hook on the left side of the W.
All right.
All right. Well, that's all I have, Gary. Do you have it? You want to talk a little bit about the
You know
upcoming?
what? I'm just let me just say a couple things. I'm not going to try to get my machine. Well, actually, it looks like it might work. There we go. So just setting the stage, we were trying to show this data moving around the entire asset management lifecycle. So from a business standpoint, any transportation agency that's involved in design is generating lots of CAD BIM files, and we want to create mechanisms to allow that data in a zero loss, seamless manner to move around that whole asset management lifecycle. So I hope you feel like you saw Eric demonstrate that capability. There's probably some work to do on the CAD side, it sounds like, when the data comes back from the GIS environment to ensure some of the CAD standards. And obviously there's the accuracy levels of data. The GIS environment is perfectly capable of storing the same level of accuracy. A lot of people, I feel like, have this notion that GIS data is not as accurate. It's probably deserved in some instances because it's captured in a way that's not as accurate as the surveyors and the design folks do sometimes. But if you've enforced those same accuracy requirements on any data being put into the GIS environment, then that data will return back just as well. I wanted to just show, it's a little bit of a teaser. We aren't showing it today, and I realize that especially for the state DOT customer base, it's still predominantly a MicroStation environment, but we are corporately doing quite a bit of work with Autodesk to take advantage of some new technology, some new capabilities, using a services-oriented architecture to allow their BIM and 3D design products, InfraWorks, Civil 3D, BIM 360, it seems like I'm forgetting Revit, to allow them to be able to consume ArcGIS data through services. And the eventual goal is to build that product family out to the point where we can, through services, move this data around the entire workflow. So the next webinar, maybe we'll be showing some core products that have been built, at least in the Autodesk environment, to be able to show that. Some of the resources that Eric referenced in the webinar series are available there on that. And with that, I'll open it up for maybe one or two more questions if anyone has them. Is it good to create a CAD thematic base file before importing them into the GIS? I'm not sure I completely understand that question. You might have to help me out with.
That doesn't ring a bell to me either.
Is Bentley playing nice on the Esri development efforts? I would definitely characterize our relationship with Autodesk much tighter and at a much deeper level from a development standpoint. I've been around the Esri for 28 years, and I know that we've reached points where I felt like we were going to end up with the same level of integration with Bentley, and for some reason it just never quite panned out. I'm not sure I know exactly why, but what are some good resources that can help you learn about GIS, BIM, and CAD integration and workflows? You know, I've been pursuing this whole asset management lifecycle for the better part of 3 years, and unfortunately, I'm not sure that I've found a ton of information. There's lots of information about the individual pieces. I would encourage you to try to just get in touch with us, and we can work through some of that with you. I don't know, Eric, do you know of like resources that would help people more with the GIS, BIM, and CAD integration?
No, not really. Unfortunately, it's just all been learning as I go and experience from my
Yeah.
land records days. I mean, that's where a lot of the CAD integration experience comes from that I have.
Okay. Are there classes in ArcGIS for creation of Python tools that support the workflow shown today? So, yeah, we definitely have Python classes that you can take to learn how to do that kind of stuff. Putting some of the ArcGIS functions in there, you may need to learn some components and pieces of ArcGIS as well. But that's something that we can point you in the right direction.
For sure. Yeah, there's that was all purely the Python I wrote. There wasn't a lot, but where it was using the geoprocessing tools through Python and the Python API for ArcGIS to intermingle with ArcGIS Online. So the publishing portion of which I didn't show, but I included in the scripts, reaches into ArcGIS Online. So you have to know how to log in, and all that's done programmatically. And all those things are parameters in the tool. So you have to provide a username and password so that when the tool logs in as you, it can publish the service. So that's all part of the tools.
Right. Hey, so there was a clarification on the question about the base map development. It says, is it a good idea to create CAD thematic base files before importing them into the GIS? And the clarification was like in utilities only or topo only. So I guess if you're trying to view the CAD data in the GIS environment, there are lots of base map options that you have over in the GIS. Just through our ArcGIS Online, there's imagery and all kinds of things, and you can create your own. So I guess the answer is if you wanted a topo base map to be part of the background for the CAD file that's come over into the GIS, you could either have the contour lines themselves drawn from the GIS environment, or you could have a base map that was more of a topographic looking map. In fact, I think that's one of the options in our base maps is a topographic map, isn't it, Eric?
Yes.
Yeah. All right. And then we had another question about which ArcGIS folder the PRJ files are in.
Yeah.
So that's those. You said there were 58 of them or something, or 580 of them.
There's roughly 5. Yeah. Where the projections are stored. Is that the question?
Yeah.
Sorry,
I think it's asking like where do you go find state plane for South Dakota or something.
Got it. Yeah. So in I'm looking here. So inside of ArcGIS, so I went to program files x86. I have a 64-bit computer, so I have an x86 folder for program files. ArcGIS desktop, I'm using 10.5 at the moment. And then from there, it is going to be under. Are
you going to be able to find? Maybe we can send that out to everyone.
We'll
Ray,
send
remind us to send
a link.
Yeah, where the PRJ files are actually stored in the ArcGIS install process.
Yep.
You got it.
Do you know if we've had DOTs that have used Collector to edit CAD data?
No, I don't. We talked to Utah about it, but no one's done it yet that I know of.
Okay. Just from an observation perspective and having attended GIST quite a few years in a row, I mean, this question comes up every year, and it's usually in like the top 3 requirements or goals is for people to help figure out this CAD to GIS to CAD integration. And I think Eric pointed out some of the challenges. We have quite a few states that I know have design standards for their files, and then, but then they aren't always adhered to, or they don't always get their as-built drawings. So the migration of the data becomes challenging or not as useful, because if they aren't getting the as-built, then they're getting an erroneous representation of what's actually in the field. And if they don't adhere to the standards, the automation that you saw Eric create and run falls apart, because that automation is obviously dependent upon that CAD standard. So there's lots of room for improvement in this area. What I hope you saw today is that there are tools out there. If you will work through the process, you can get this to work. All right, I appreciate all the questions that everyone asked. It makes it a much more informational process. And if you have any questions or further needs for talking to Eric and I'm sure you'll be able to find us. I think, Ray, you'll send some information out to everyone that lets them know how to get in touch with us.
Yep, absolutely. I'll get resources, information on the recording, and your contact, so that that'll be available to them within a week or so.
All right. Well, thank you, everyone. Have a good afternoon or morning, depending on where you are. We appreciate it.